Hi everyone, my name is Janine Ko and I make educational related videos like this. So if you're interested in seeing more, please subscribe to the channel and hit the notification bell. So for today's class, I will be covering limits by direct substitution. So as you can see, as the word substitution implies, that means you just take your x value and then you plug that into your x and then you evaluate the limit. So for number 1, we have limit as x approaches 3 and you have a quadratic equation which is 5x squared minus 4x plus 12. So we take 3 and you plug that into your x, so you would have 5 times 3, you square that, then you have minus 4 times 3, and this is plus 12. So as you can see, because this is negative 12, ultimately the negative 12 and the positive 12 will cancel out and become 0. So therefore, your limit is going to be 3 squared, so that's 9, times 5, so that would be equal to 45. So let's take a look at number 2. So you have a rational function, so it's x squared minus 4 over x minus 3, and you're supposed to find the limit when x approaches 2. So again, substitution, just plug in 2 into your x, so you would have 2 squared minus 4, and this is all over 2 minus 3. So as you can see, your numerator would result to 4 minus 4, which is equal to 0, and in your denominator, you would actually have negative 1, because 2 minus 3 is negative 1. So 0 divided by any number is always going to be 0. Therefore, your limit as x approaches 2 is going to be 0. So for number 3, if you have limit and you have a parabola which is negative x minus 3 squared plus 2 when x approaches negative 5, when you plug in negative 5 into your x, you would get negative 8. So in this case, because you have negative 8, you're squaring that, therefore it becomes positive 64, and because you have a negative sign outside your bracket, you would have to distribute that into positive 64, and as a result, you would get negative 64, and this is plus 2, therefore the limit when x approaches negative 5 is going to be negative 62. Now, for number 4, you have a polynomial function, which is a cubic function, and then you need to evaluate the limit when x approaches 0. So all you have to do is you take 0, you plug that into your x, and you find a limit. So this is going to be negative 0, this is cube plus 6 times 0 minus 2. So as you can see, this is actually 0, this is also 0, and you're resulting to negative 2. Therefore, your limit when x approaches 0 is going to be negative 2. Now for number 5, you have to evaluate the limit when x approaches 2 and you have a rational function, which is x over x squared minus 9. So all you do is you take 2, you plug that into your x, so you would have 2 over 2 squared minus 9. So as a result, you see that your numerator is still going to be 2, and your denominator is going to be 4 minus 9, and we know that 4 minus 9 is actually equal to negative 5. So you would have 2 over negative 5. So your limit when x approaches 2 is going to be 2 over negative 5. Moving on to number 6, we're supposed to evaluate the limit when x approaches negative 3 and you have a rational function again, which is x plus 7 over x plus 3. So again, same thing, substitution. So you apply this negative 3 and plug that into x, so you would have negative 3 plus 7, and this is all over negative 3 plus 3. So as you can see in your numerator, you have negative 3 plus 7, so that actually gives you 4. So you would have 4, but your denominator would result to 0. So this is 4 over 0, and we know that any number divided by 0 is always going to be undefined. So in that case, your limit when x approaches negative 3 is going to be, well, it does not exist. So limit does not exist when x approaches negative 3, and when you have a rational function which is x plus 7 over x plus 3. Okay, great. So for number 7, you have to find the limit of tangent x when x approaches pi over 2. So from what we've learned so far, anytime you're looking at tangent x as a function and you're looking at x is equal to pi over 2, you're going to see that there is an asymptote. Specifically, there is a vertical asymptote. However, if you were to illustrate tangent x in terms of sine x over cosine x, then you would have to plug in pi over 2 into your x. So you would have sine x over cosine x, and then you're going to take your x and replace that with pi over 2. And then take your calculator with you, and just make sure that your calculator is in radian mode. That's very critical. So type in sine pi over 2 in your calculator. So you're going to see that this is actually equal to 1. And for cosine pi over 2, so just plug in cosine pi over 2 into your calculator, you're going to see that this is actually equal to 0. So 1 over 0 is undefined, as you can see. Therefore, that's the reason why when you're looking for the limit of tangent x, when x approaches pi over 2, your limit is actually undefined, or it does not exist. Great. So for number 8, we can move on. So we would have limit when x approaches pi and you have sine squared x plus 5. So as you can see, when you plug in pi into your x, so you would have sine squared and this is pi, then you would have plus 5. So take your calculator, make sure this is in radian mode, and you would have sine pi in your calculator. So you see that it's actually 0. So therefore, if you have sine pi and you square that, so 0 squared is actually 0, and you would have 0 plus 5. Therefore, the limit when x approaches pi, that's supposed to be 5. Okay, so for number 9, you have limit of sine x plus cosine x when x approaches pi over 4. So again, because it's direct substitution, really all you do is you plug in pi over 4 into your x. So you would have sine pi over 4, and this is plus cosine pi over 4. Now take your calculator with you, you plug in sine pi over 4. As you can see, you're going to get square root of 2 over 2, even for cosine pi over 4, if you type this into your calculator. So you would have square root of 2 over 2 plus square root of 2 over 2. And because we want to combine the two fractions together, you see that this is actually square root of 2. And just so you know, there is a quick way to actually combine fractions without your calculator. So what I do is I use what I call the butterfly method. So I cross multiply 2, or maybe let's use a different color so it's easier to see. So you cross multiply 2 times square root of 2, so that would actually give you 2 square root of 2. And then as a result, because you have your denominator, which is 2 times 2, right? So you actually have to multiply 2 times 2, which is your denominator, and that would give you 4. And then ultimately, because there is a plus sign, that's why you have a plus sign over here. And then you have to cross multiply 2 times square root of 2, which is going to be 2 square root of 2. So can you kind of see the variation as to why I call this the butterfly method? It's because it looks like a stick butterfly in that sense. So in this case, as you can see, we can factor out 2 square root of 2. And then we're left with 1 plus 1, right? Because it's the same thing. So 1 plus 1 is 2, right? So in our bracket, you would have 2, and this is all over 4. So you can simplify 2 square root of 2 times 2 over 4. So that would give you square root of 2. And that's how we arrive to our final answer. Now, if you look at number 10, we do have a square root function, or we have square root of x squared plus 9, and we need to evaluate the limit when x approaches negative 4. So we just plug in negative 4 into our x. So this is negative 4, you square that, and this is plus 9. As you can see, this is going to give us 16, or square root of 16 plus 9. And when we try to evaluate 16 plus 9, that's going to be 25. And we're supposed to find the square root of 25, and we know that that's going to be 5. And there you have it. Hopefully this session was very helpful. If you're interested in seeing more classes like this, please don't forget to subscribe to the channel and tell your friends.